So, for the skeptical of you, I'm not actually pushing 80 gigs. It's a good way of getting people to come in the morning or come to my talks and things like that. There are 160 gigs worth of SFPs in the firewalls that we dropped in, but we are not pushing 80 gigs. So, as with all firewall things, the numbers aren't quite true. So, my name is Llewellyn. I currently, among other things, run AS28715, and this talk is about AS202119, which I'm no longer involved in. So AS202119 was a startup handling lots of social media data, coming in, processing it, searching for stuff, and then pushing it back out to customers. In 2011, it was, I think it was about 8 managed servers. By 2015, we had over 40 racks across 3 DCs and a network that looked a bit like this. We were doing stateless firewalling on the routers and then allowing the hosts, which were managed by Chef, to use IP tables to manage their own stateful firewalling. So we allowed 18443 in and packets sourced from 18443 and back to ephemeral ports at the edge. Within the network, let's go back a sec. So we had 10 gig to the core, or the spine switches, which were Arista switches, and then 10 gig out to transit and peering. Back into the network, we had 10 gig, or 2 10 gig links to each top of rack switch, and 10 gig from the spine to each router. So it was quite nice. It was 10 gig everywhere apart from the hosts, which were obviously 1 gig. Routers 1 and routers 2 in the diagrams are Cisco ASR 1002Xs, 3 and 4 were ASR 1004s. Core 1, Spine 1 and Spine 2 were Arista 7050-52s, and Core 2, which was in another DC, were 7050-128Xs. So lots and lots and lots of 10 gig ports for expandability and stuff like that. And all was good. You know, Chef handled our firewalling, servers automatically added new rules when new servers were added, when new sources were added, and it all self-repaired, and it was all beautiful. And then the company went for SOC 2 compliance. And SOC 2 told us that firewalls on the hosts was no longer good enough. We had to have a stateful firewall at the edge, at the perimeter, and there was no two ways about it. We had to take this network that was pushing many gigabits, not 80, and drop firewalls in. Now, the problem we had is that we couldn't drop a single packet, a single what we called social media interaction. We had customers that were paying a lot of money waiting for that one thing to be said, whatever that may be. So we couldn't risk just dropping in some stuff and it all going horribly wrong. So it was quite scary. I had some requirements myself. The business comes to me, they say, I've got to drop in firewalls, can't have any downtime. So I was like, cool, it's going to be expensive, but I want one-to-one contention within the DC. So I've got 10, 20, 30 gigabits worth of transit capacity on my routers. I don't want to be putting in a firewall that's only got 2 1 gig NICs back to the LAN. And I didn't want it to cost the earth. Obviously, I had a budget, and I'm sure everyone can appreciate firewalls at this spec aren't cheap. But I went and I had a look, and I went to Cisco, and I was like, right, what has 4 10 gig NICs and has some form of transit? And they were like, all right, yeah, the ASA5585X, SSP20, SSP40. And so I was like, oh, brilliant, excellent, yeah, cool. Send me some quotes. And obviously you can hear the salesperson getting really excited. And the quotes came through, and I kind of cried a little bit. It was far more money than that I had for my budget entirely. And that, obviously it's the first thing that they put, you can negotiate down. But it was great, because for me, I didn't want to spend that money. I had an idea. Within AS28715, I use OpenBSD for everything, my routers, my firewalls, my servers, and I had this excellent opportunity where I was like, oh, I could also use it here. And I'm not sure how many of you have been able to take Cisco on one side and then go, there's this OpenBSD thing that no one's ever heard of, and I want to use it for our firewalls, and try and convince the CEO, CTO, and all the other people that this is a good idea. But they looked at the numbers, and they were like, and you say it won't go down. I was like, I won't say won't, but it's basically free. Let's give it a go. Now, the platform within AS202.119 was predominantly DL360 Gen 8s. So they've got 2 PCIe slots, a lot of RAM, and some very nice CPUs. And we had hundreds and hundreds of these servers just sitting around. So all I had to do was buy some X520 NICs, which are 2 10 gig SX SFP NICs. Gives me 4 10 gig ports per server, a couple of servers, lots of lovely warm spares if anything horrible happens, and lost train of thought, sorry. So yeah, if I had any issues, I could just literally yank out the NICs, yank out the disks, re-image, and then we're back up and running again. Now, I couldn't, we're a social media company, we liked tweeting and telling things, but I couldn't really tweet that I was dropping in firewalls because we didn't have any. So I also took the opportunity to deploy V6 properly within the entire network. So most of the tweets that I was sending at the time were about, we're rolling out IPv6, we're actually coming to the future. And there's one of our DL360s with the 2 10 gig NICs. And I'm standing there telling everyone everything's going to be fine, we'll use servers, we'll use OpenBSD, it'll all be good, it'll all be great. And then, one of the servers failed. I'm not sure how it's going to show up on the slides, but that right-hand picture near the bottom is where the magic smoke escaped. Thankfully, it didn't set off the fire alarms at the DC, because that would have been even more embarrassing. But we had our failure, things carried on as they were supposed to, and we weren't actually live yet. So yanked out the NICs, yanked out the disks, we were all up and ready and good again. So this was our starting point. For better or worse, we had area 0, which was for OSPF, from the 10 gig NICs on the top of rack switches, up through into the routers, and then to the other side and the other DC as well. For better or worse, we thought of our cabs as a unique or contained item of compute. So it was its own independent resource of DB, memcache, all that sort of stuff. And so it made sense that it would be its own OSPF area as well. As we transitioned through it, we changed this design, and I'll show that in a bit. Oh, there. So yeah, each DC would eventually become its one area, and then area 0 would be only in the core between the routers. So first step was we plugged the OpenBSD devices into the spine, set up some static routes so they could reach the internet, we could talk to them, but nothing was happening. Everything was still OSPF, everything was still happy, just wandering around, moving along. We then put in static routes on everything to spine 1. So OSPF was still running on spine 2. But static routes had the higher weight, so everything was going nice over there. Unplugged the OSPF links from the routers, dropped them into the BSDs, removed all the other OSPF configs, so now everything was going through this one spine switch. And obviously we were at great risk at the moment because obviously we'd lost that spine switch, we were kind of screwed. Slowly added a couple of static routes here and there, see what happened, make sure everything was going okay. And then we brought up OSPF as well as the static routes. The static routes were still controlling everything because they had the higher weight. OSPF was working, we could see that the BSDs were doing what they were supposed to do, that the area 1 versus area 0 stuff was doing what it was supposed to do, and OpenOSPFd, Cisco's and the Aristas were all cooperating, and I was looking pretty good at this point. It's like, yeah, we saved a lot of money, everything's routing, doing what it's supposed to do, it's all good. Not so much. We're all stood there, we started removing the static routes, and then every single monitor that we had went red. The DevOps people's screens went red, the BizDev people's screens went red, our pages went insane. There is or was a bug between the way that Cisco, Arista, and OpenBSD calculate link state updates or checksum link state updates. And the Aristas decided they saw a loop and so they null rooted every single route they learned. Luckily, we still had our VPN statically routed, so we were able to get in there, put back the static routes and panic over. Unfortunately, this idea of not having any downtime, not losing any packets, suddenly went horribly, horribly wrong. But we recovered, triaged with Arista, and we had a bug that was created, and we updated, and everything was good again. So, with our new updated software, we were able to have our statics, our OSPF, and everything else up and running and ready. And removed all of our static routes and saw that everything was working beautifully. So we were really happy. We had our firewalls running, we had our OSPF running, following the bug, and we had our stateful firewalls in place using OpenBSD. So obviously we were only using a small amount of, we weren't doing the full 80 gigs, but we had a reasonable amount of traffic running through them across both DCs, and everything was quite nice. Now, I mentioned that we also took the opportunity to do IPv6 at the same time, and our wall was covered in literal checklists. So we printed these out at A3 size, and as we went along, we actually literally ticked off what switches we were working on, what firewalls we were working on, static routes added, removed, adding IPv6 at the same time. So when we had the giant explosion of doom, we were able to actually look at the diagrams and immediately see what switches were affected, were the ones that had all been ticked for the removing the static routes and allowing OSPF to do its thing, which actually worked out to be very, very useful, better than Jira tickets or whatever else that people might use for a project of this size. So other than the epic failure of everything going offline, we had some other pain points. With pairs of firewalls in DCs, obviously you need to sync the rules between each other. We had 4 10 gig interfaces, but chose to only use a 1 gig interface for syncing the state. Now, you would possibly think that the problem we had was too much traffic and not enough link state update, or being able to pack the amount of link state updates or rule syncs between the firewalls based on the traffic that was being pushed. Because we'd allowed OSPF to be completely equal, we'd have a packet going out of one firewall and then coming back in on the other, and the link state or the rule sync update hadn't managed to reverse one firewall to the other yet, because PF likes to bundle them up and send as little over the wire as possible. So we can drop what they call max upd, which is the amount of updates that get put into one packet. But then, of course, we then push for every packet we send out, we almost send out a link state packet. And at that point, you know, multiple 10 gig interfaces and a 1 gig interface fail. So we did a dirty hack. We changed the OSPF weights on the firewalls. So we had the idea of a primary firewall and a secondary firewall. The idea being that if we lost a firewall, which would generally be what we'd call a catastrophic event, TCP and all the rest of it can handle itself. We designed, I mentioned earlier that we had this idea that a cab was an independent unit of compute. So the platform was designed to recover from the failure of one or more cabs, or in fact even an entire data center. So with that in mind, my argument was that, you know, if we lose a firewall, TCP can re-establish, we'll work out what was missing and backfill. And that was allowed. So that worked quite well. DDoSes. Now, I'm sure many of you see much larger DDoSes than 11 gigs of additional traffic. Ours were a bit strange. They only targeted our web spiders. Every week or so, we would get 11 gigs worth of traffic, usually sometimes more, sometimes less, directed specifically at these 1 or 2 of these web spider servers. We never got any emails threatening it or asking for Bitcoin ransom or telling us that we were horrible. Just out of the blue, DDoS stopped after an hour or 2. PF and the OpenBSDs didn't like this. They would start dropping packets, and we'd see issues, obviously, with the legitimate traffic coming through. And because we'd usually just blocked this at the ASRs and they just absorbed it quite happily, dropping the packets rather than having to evaluate them because it was a stateless rule, the business were like, well, you can fix this by just pushing it back up to the ASRs. We don't want you to waste any more time, lost packets and customer confidence in trying to diagnose it. Obviously tried pushing the argument that when we reach 11 gigs or 20 gigs or 40 gigs per NIC or per route per firewall, then we might see these exact same problems, so let's fix it now. But the argument was, this is DDoS traffic, it's different, blah, blah, blah. So unfortunately, I couldn't find out how we can use PF to potentially soak up these DDoSes. And finally, syncing rules. Obviously, with ASAs and things like that, you write the rules on one device, and then it handles syncing the rules over to your other device. OpenBSD is they are independent boxes. It's a server that's running there with the daemon running, and it's up to you to sync the rules. Now, we used Chef on all of our actual servers, and there is a Chef daemon for OpenBSD. We hadn't got round to deploying it yet. So what we were doing was making a change on the primary, checking the config, reloading it, remembering that we had a secondary and a third and a fourth and a fifth, and then going out and manually going to each one, which wasn't particularly great. There are ways of using PF tables and BGP or other various cool and interesting things. Unfortunately, I left before I was able to try any of these and put them into production. So, woohoo! I have my firewalls, I have my routers, I have this lovely ring, everything's great. There ended up being a bit of a problem. We were running IBGP, obviously, between all of our routers, and we were noticing that routers 1 and 2 were getting quite upset with each other. And the difference is we'd thought to put a 10 gig interface between routers 3 and 4, so they wouldn't have to traverse the OpenBSD firewalls to do their IBGP. Major oversight of ours. We hadn't allowed the rules, there was hairpinning issues, and a few other bits and bobs like that, which meant that routers 1 and 2 were ending up going through 3 and 4 to do their BGP. It was horrible. Oh, my slide is a little bit off. 1002s only have 3 10 gig interfaces. So we'd either have to put 1 gig interfaces between the routers, which isn't ideal, obviously, if they try to send 10 gigabits worth of traffic through each other, if they lost one of their links up to the back to the core. So instead we did something a bit naughty, and we carved up the spine switches into some VLANs, dropped the 10 gig interfaces into the VLANs and did it that way. So it worked, not pretty. However, that DC is due, or was due, for decom. So the idea is we'd do that horrible little hack, and then once we get up to the next data center, which would be 5 and 6, which would again be either 1004s or 1006s, we could get rid of these 1002s and the horrible hack of having to use VLANs to do the IBGP and stuff. There's some pictures, just because. Those are the Arista 7050 128s on their way to being built. Unfortunately, I didn't have any nicer pictures than being full, and our 1004s. And then there's the BSDs full of fiber. And a little thing, so I've never bought an operating system before until I decided to use some open source operating system for something, and then I actually bought it, even though it's free to download. Bit weird, but you know, we were using them for a business. Interestingly, the business wouldn't buy it. They were like, well, it's free. I was like, I've already saved you hundreds of thousands of pounds. Can we? And then they went, no. So yeah, I've now got a collection of nice OpenBSD CDs, which they've stopped making now, which is a shame. But so, any questions?
Hi, Nat from Bytemark. During that DDoS, and overall, I guess you've tested it, what kind of PPS through the kernel were you managing to get?
I didn't check that, to be honest with you. Most of our traffic was HTTP based. To be honest with you, I have absolutely no idea. I could ask, go back and check with one of my colleagues and get back to you, find out what it's doing, but it wasn't very interesting numbers. We did hit the state table in PF quite a lot of times. We had to boost that a lot, up to something like 200,000 entries, but that wouldn't necessarily reflect on the PPS. So yeah, I'll ask my colleague and I can get back to you, but I couldn't. It wasn't anything particularly exciting, that's for sure.
Hi Gareth. Great presentation. I think the thing that I'm surprised about is getting away with using one vendor firewall on such a complex platform. So, you know, because you have an issue with that firewall, then you're exposed. Mm-hmm. So typically we're, in a lot of applications like this, we're having to put 2 firewalls in so that if one is exposed or someone does something stupid in config, you've got kind of a backup. Did you not have any issues with that?
So other than the, when it all went horrifically wrong, it was a consideration, but we, as with the DL360s, we were very much cookie cutter. So the idea is that the software and the application and the platform itself would self-repair against any major issues. So we wanted everything to be as standard as possible. So all servers were CentOS, all switches were Arista, all firewalls ended up therefore being OpenBSD. It would have been nice if there were other options. I believe there is, you know, PF has been ported to Net and FreeBSD. However, there are concerns about those other things that may or may not cause the same problems. So it was a consideration, but since we cookie cutted everything else, it made sense to standardize there as well. But yes, it was potentially a risk, as we then saw. Anything else? No.
Okay.
Cool. Thank you very much.
Questions for Gareth? Okay, thank you.
Cool, thanks.